Okay, welcome everyone. This is a very little talk, and I'm not going to talk about packaging this time. Simone. So there is a main part and then a bonus part 2. The idea is to look at a specific feature that is in Odoo, which is the xsend file optimization to serve attachment. So we'll look at what it is, and in particular we look at how to use this optimization when you are in a cloud deployment and your attachments are stored in S3 buckets or similar. So a quick recap about the Odoo file store. You probably know about it. That's the part that stores the document and some binary fields of Odoo. It's a smart system. It's nice. It's very simple. It stores them on a regular file system, and the files are named after a content hash of their content. That's why you see these files. And the content of those files is immutable, so once a file is in the file store, it's never modified. And if you put the same file twice in the file store, the same is reused. So those are interesting characteristics. They can be deleted, so if you delete a record, in some situation there is a garbage collection and those files are deleted. So it's simple, it's very easy to deploy, and works pretty well. And you will see some sequence diagrams. So the idea is that how it works is that when a client, a browser, requests an attachment, it typically goes to the proxy that is in front of your Odoo deployment. Odoo, the proxy forwards the request to Odoo, which first checks if the user has permissions to access the file, and if yes, it reads the content and sends the content back to the proxy, and which in turn sends it back to the user. Just a quick tip, there is an option in proxy to ask the proxies to do buffering of the replies. If it's not enabled by default in your proxy, and for instance in Kubernetes the nginx ingress does not activate it by default, I recommend to activate it, because the proxy will consume the result as quickly as possible and then free the Odoo worker to serve other requests. And the proxy is highly optimized to serve a large amount of concurrent requests and files. That's what it does best. And so you free your precious Odoo workers to serve other business requests, instead of sitting idle, sending data to maybe a client that is on a slow network connection and taking time to swallow the reply. Odoo, since a few versions, has an optimization to this mechanism. This is the xsend file option. It is in the Odoo documentation. I put the link here. With the Apache proxy, it's called xsend file. In the nginx documentation, it's called x-axel redirect. It's the same basic principle. And the difference in the sequence is that in that case, Odoo will check the permissions, locate the file, and instead of returning the content, is returning an HTTP header, which is called xsend file or x-axel redirect, with the location on the file system of the document that must be sent to the client. And then with some configuration in the proxy is going to directly read the file from the file store and send it to the client. So that's also better, because even with proxy buffering, because the proxy does not need to buffer, it has access to the file and can read it and send it as fast as the client can read it, but the Odoo workers are freed as soon as possible to read the content. So it's a little optimization, but Odoo workers are hungry in terms of resource. They consume a lot of memory. And instead of adding workers, if you see that some workload is spent sending files, it can be a solution to reduce the workload on your system, or the memory usage at least. And probably nginx or Apache is probably more CPU efficient also to send the files than Python. Now, in some situations, this file store stored in a simple file system is not enough. In particular, where you have multiple Odoo instances on different machines that all need to have access to the file store. In that case, you need to mount the file store on the different machines, which increase complexity and also impacts performance. So in that case, it's interesting to consider another solution, because managing either an NFS or Ceph file system can be quite complex. Object storage, typically S3, the equivalent at Azure or Google, are a typical use case for these kind of files, because those files are immutable. You never modify the content of a file, so it's a good use case. You get automatic scaling. As your file store grows, you typically don't have nothing to do to add capacity. And it's typically cheaper if you're in a cloud deployment to store this large amount of files in buckets in object storage than on classical volumes, because the classical volumes, you need to pre-reserve the capacity, then increase it, so you consume more than what you need, and then you need to do something when you need more capacity, and also there is some limits that you typically don't have with object storage. And even for self-hosters, I personally find it easier to maintain the Minio instance, for instance, which is an S3 implementation. I find it simpler than maintaining an NFS or a Ceph implementation. So that's where the FS attachment in the OCA storage repository comes into play. It allows you to at the core, give you an abstractions for abstract file systems, thanks to a Python library that is called fspec. It gives you the little abstractions of a file system, and the files can then be stored anywhere depending on the backend you install. It could be object storage, it could be traditional files, it could be document management systems, or basically anything. So this FS attachment, it has and storage has a long history with contributions from Cap2Camp, from Accretion, and Laurent at Axon. It's very well documented at this point, so you can look at the documentation to learn how to use it. And there was a talk two years ago about it, so have a look. So to use it, you simply install this FS attachment module, and then you need to define the storage backend. So you need to tell it where it's going to store the attachment. And the configuration typically looks like this for S3, but it's very similar for other object storage. So you need to give it a code. Typically you have a different storage backend. That's not mandatory, but recommended. You have a different storage backend for each environment, for production, acceptance, test, or whatever. You give it the protocol. The directory path with object storage is the bucket name. And then you have a configuration that depends on the storage backend. It looks like this for S3. You say where the endpoint URL, if you are not using Amazon, you need to configure that, the access key and secret, and possibly the region. And then you have a few things to check. The most important one is use as default for attachments, which means that when FS attachment is loaded, all attachments will be read and written in, well, first written and then read in that storage backend. Other options to use is use file name obfuscation, which is the mechanism where you get the hashes of the files as file names. And that's basically it. You need to install the S3 backend of the fspec library, which can do with a simple pip install. And basically, there you go. That's all you have to do to start using it. Now, if we come back to this extend file optimization, you start to see the problem because the reverse proxy does not have access. Before he was looking in the file store, in the local file system. But in this case, we want to read in what is typically a private bucket for which you need credentials to access it. And Odoo has the credentials, it's in its configuration, but typically your reverse proxy does not have them. And there is a simple solution which is now embodied in fs attachment underscore S3, which is a little specialization of fs attachment for the S3 backend, which on the one side supports MIME type, so it's propagating MIME types to the backend. But also if you enable the extend file option, what it does is that it returns to the proxy in this HTTP header here a pre-signed URL that gives access with a short time to live. It returns that to the proxy, which can then read it directly from the private bucket. Those pre-signed URLs is a mechanism that is supported by S3, but also by Google and I think Azure too, which is a mechanism to distribute access to, it puts a kind of token inside the URL, which gives access, can give access to private objects for a temporary time period. So that's very convenient in this case. And then you have a bit of configuration to do in your reverse proxy. In that case, for technical reasons, we cannot return an HTTP or HTTPS URL directly. So what you have to add in your reverse proxy, this is nginx syntax. You put a regular a location with a regular expression where you extract the scheme, which is going to be HTTPS, the host, which is going to be your S3 bucket host, and then the rest of the path is going to be the pre-signed URL. And so with this, which is called an internal location, which is not accessible from the outside, that's this mechanism takes place only when the proxy receives something from an upstream server. It will pass the request to the S3 bucket. And so we are back to this mechanism where all the workload of serving the attachment is back to the proxy. And it's even more important to use it than with the file system backend, because typically it is slower to read from a bucket than reading from the local file system. And Laurent has done some tests. In some cases, he has seen that where the worker was typically spending 200 milliseconds to read and serve the attachment, it was down to only 20 milliseconds to check the permissions, so you can free and in the end work with less workers for an equivalent workload. And of course, if you serve large files, it's even more important. Work to do, we have not checked, probably that does not work yet. In principle, it's possible to do the same for upload, but to be investigated. In this topic, one last word. You may have seen that in Odoo there are now 3 modules called cloud storage, Cloud Storage Azure and Cloud Storage Google. This is a bit the same principle, except in that case, it's the client that's going to access the bucket directly. I've never used it, but I spent some time reading it. So the mechanism, if I read correctly, is that Odoo is returned the pre-signed URL to the client, and then there is some JavaScript code that is going to write or read the attachment directly to the bucket via the pre-signed URL. As I understand it, you need to define the minimum file size at which point this mechanism steps in. So you still need the regular file store, but it could be complementary. For instance, if you need to upload a video to a bucket, that could be something worth investigating. And that's it for this first part. A simple tool. And the second part, just a quick word. It's something that came to us. That's about the static asset, so it's really related to that. If you look into the Odoo deployment recommendation, they recommend to configure or reverse proxy like this. And those static files are icons, some JavaScript CSS code, or could be embedded JavaScript libraries. It can be useful, not that useful, because many assets are aggregated in bundles before being served and end up being attachments anyway at some point. But in some cases it can be useful, especially in debug mode. You get much better response time in debug mode when you have this configured, because in that case it reads the assets directly. And so the mechanism here is that the client requests the static file. Odoo is going to read it in its own source code and return it to the client. And what that configuration does is that it's the proxy that, in that case, it doesn't even involve Odoo. If it's a static file, it goes directly to the Odoo source code. But in a cloud deployment, your ingress typically does not have access to your Odoo source code. And also the add-ons can be in different directories, so it's not easy to find where they are stored. So a little idea is in Django there is a tool called collect static that is recommended to use in production deployment. That's going to collect all the static files and put them in one place where you can serve them. And you can totally use that. A collect static script is this, so it's very short. You don't need much like that. You browse the add-on path and look at all the static directories. And then, even if you have a complex add-on path, you have the simple configuration recommended in the Odoo documentation. And for cloud deployment, where your assets are typically in a Docker image where your ingress does not have access to, what you can do is have an init container. So when Odoo starts, you collect all the static file, you put them in a temporary volume that is mounted in a little nginx instance, and then route the static routes to that instance. So small little idea that I found funny and wanted to share. It's not worth spending a huge amount of time on that unless you have a situation where you serve many static assets, because as I said, the main one, the JS and CSS, are bundled anyway and end up as being attachments. So the first part is much more important for that than just spending too much time on that. But I wanted to share it. And that's it today. Simple one. Questions? Yes?
Thanks. Very interesting talk, as usual. Thank you. One question regarding the setup for getting the token, let's say the unique token, the short-lived token for the S3 storage. is there any particular setting to be done on the S3 storage itself? Like allowing access with the token or what? Something like that?
Two checkbox. Yes, so you have just two checkbox to set. First to say to use the XN file and then to use the signed URL for...
So nothing to be done on the setup of the S3 storage itself?
No, it's managed by the S3 client library, actually. It's not even doing a call to the backend. It generates the token based on the access and secret key. And so it's yeah, very efficient. Other question? Yes.
Well, once again, thank you. And questions. I'm not a specialist. I know what we have developed, but I'm not the developer involved there. We are using now Fuse. I don't know if you are aware of Fuse. To mount the S3, so we are not using anymore any add-on to map the files to the S3 objects. For us, it was a win. It simplifies a lot. Everything, backups, everything is more standard. But I still believe that the approach of serving the URL directly, maybe a module that can return that URL to access the object, could be done also in that ecosystem. I am thinking correctly, and it makes sense maybe to...
In that case, you would need to have a mechanism to mount the file system in an HTTP proxy, one way or another. It can be an intermediate proxy that does that. But then I worry about the security implications because...
But the Fuse is it's in charge of uploading the objects and receiving them and delivering them as
yes.
a file store. So the objects are there the same as they are with this module.
Mm-hmm.
The idea would be a simpler module that when you
yes.
return an asset, we could return the URL with the same mechanism.
Yeah, I think it can work. But you would need to mount your Fuse file system in the proxy too,
okay.
And then that will work with the standard Odoo XN file option.
So this is related to the second question. To deliver the static content on nginx, we have mounted an nginx in front of each Odoo.
Yes.
And we also have the ingress. So that way we can reuse that nginx for both things. If you
mount your Fuse file system in that nginx, it should work.
Okay.
With the standard Odoo option. Yes.
Okay, perfect. Thank you.
Welcome. Other questions?
It's not directly related, but a little bit related because we are speaking about reverse proxies. Do you cache at the reverse proxy level?
No.
Okay. Say it in the mic. Do you?
Sometimes. Not always.
So this one is FS attachment. There's also this FS storage and storage backend as part of the OCA storage repo, right? So both of them seem to do the same thing, FS attachment and the FS storage with storage backend.
FS storage and storage backend. That was the old implementation.
Oh, is that the old implementation? I don't know. I'm still in 12, so.
Basically, initially there was attachment S3 and Azure, which were come-to-come projects, and there was also in the OCA storage repository there were these storage backend modules, and everything has converged. I think come-to-come also is migrating to using FS attachment. FS storage has taken basically the good ideas of everything and put a uniform stack to serve both the attachment from any storage backend, but also give you in Odoo an abstraction for storage system like FTP or whatever, which is relatively easy to configure, but very flexible.
So
Yeah.
going forward, do you suggest we use like FS attachment for
FS attachment for attachments,
storage and then storage backend for
no, FS storage for the rest. If you want an abstraction for FTP or other, use FS storage. And FS attachment actually depends on FS storage. So those are the modules we are going to move forward. Yes.
But still use FS attachment for attachment.
Yes. Yes, that's the one we really recommend. Yeah. That's where the energy is going forward. Yeah. Okay. Thank you very much, Dan.